Good afternoon, everyone, and welcome to the talk on solar use cases at Priceline.com. Thank you, everyone, for being here. I know there are several other important or interesting talks going on at the same time. Myself wanted to be on the one on NLP and knowledge graphs. So start with a quick introduction. My name is Vidya Ramachandran, and I am a director of the data services team in Priceline. In data services, we incorporate services based on indexing, A/B testing, monitoring services, and services based out of data pipelines. And I lead that team. So for those of you who haven't heard of Priceline.com, Priceline.com is a leading travel services provider in US. And we are part of the Booking Holdings group of companies. And the other holding companies are Booking.com, Kayak, Agoda, OpenTable, and RentalCars.com. So I just want to share with you some of the migration stories from Lucene to Solr Cloud, what our current architecture is based out of, and then the response time requirements or SLAs that we have on the system today, the use cases on Solr, search, suggest, recommendations, and so on. So for a long time, we had our services, search services based out of Lucene index. So as you all know, Lucene, the Java-based library, so we built our REST services on top of Lucene. And we did incorporate some kind of customization based on user signals. And we were serving searches based out of this service for a very long time. And everything was, we lived happily ever after. So the story is never that case with any of the software components. So we had a lot of challenges, scaling and even maintenance of code. So when I say scaling, we were really looking for a distributed index because the index was growing large as we started indexing millions and millions of hotel documents and even many points of interest. And we went from being a domestic provider to an international provider. And maintenance of code, we started to figure more and more people are not actually tweaking Lucene code anymore. They're working more on, Solr or Fusion and so on. So for these reasons, we migrated to the architecture based on Solr Cloud. So everything here is pretty standard. The Solr with Zookeeper components and other stuff. But around this ecosystem, we built some custom components. So if you look at that, we have a re-ranking piece, which is basically taking care of user signals or feedback from the user and re-ranking all the documents periodically, and that is fed back to the collection. And we also, the same signals and feedback is fed to the recommendation system, which is also in the collection. These are pretty much the custom components we have developed. So diving deep into the search pipeline. So suggest is a bigger use case for us, more than search. So the search starts with in a typical n-gram analyzer, but that takes care of the custom similarity component. So even though it's doing n-gram, it is taking the ranking that was done by the re-ranking piece and fed into the collection. So the custom similarity component is pretty much ignoring the length of the document or length of the terms and looking at the custom score that was put into the document collection. And when that fails, it goes through a phrase query, with, typically when the search has multiple terms. And this is to ignore any parts of the term that we haven't indexed in the document. So a typical use case would be like user coming and searching for a colloquial airport name, whereas the database or the collection has an official airport name. So in that cases, this phrase query helps. And then we augment it with some personalized results, or we do some localization as well. And for the ones that we don't want to choose to personalize or localize, we feed it to the learning to rank component, where more user signals are taken into account. And then there is a spell check service that basically all of this failing, it goes to the spell check service. And if all of these fail, then it goes to a fallback address service. So for example, if somebody is coming and searching for an address, rental location that is closer to their home address, then we don't typically index all the addresses. So it goes to a fallback address service, and that gives back the closest lat long, and then we do a geospatial search on top of that to render the results. So this is typically the search pipeline. So most of you would have now figured why we need the custom scoring or the custom similarity, but I just wanted to reiterate on that a little bit. So as much as Solr is good at matching and scoring, it doesn't have the domain knowledge, right? So in our case, like for example, we know that in the travel space, New York should be listed higher than Newport or New Haven. So in this case, we need to tell Solr that to take care of this custom score, or a new way of scoring the document. So that's when the ranking piece comes in. So these are the signals that are fed into the ranking process. So whatever the user typed and picked from the suggest bar, and whatever is the document type, like for example, there are many types of documents. There's point of interest documents, there could be airports, there could be cities, there could be zip codes, and so on. So each are weighed differently in the re-ranking process. And the position in which the search text was rendered, or the results were rendered, what was the position from which the user picked. So that's also taken into account during the re-ranking process, and then a normalized score is computed. This is a very simplified way of putting the score. It's much more complicated than that. And on top of this, we have the localization and the personalization. So when you as a user you're booking hotels in, say, Newport more often due to work, or or you visit Newport more for leisure, then we want to augment the results for you, and we want to boost Newport for you. So your previous search history, booking history, and others are considered, and then Newport is boosted for you in the results. Similarly, for people, another use case for boosting based on user location is say, for example, there is a city called Paris in Texas, right? And then there is a famous Paris, France. So for people who are in and around Paris, Texas, it makes more sense to show Paris, Texas as at least one of the first few results in their searches. So the user's lat long, or the user's IP is taken into account, and search results are boosted based on their location. Just wanted to say that, sorry, I went too far ahead. Just wanted to add that so just wanted to add that the personalization is done only when personalization is done only when he's searching for relevant text. So for example, you may have visited Newport more often in the past, but then when you're not searching for something closest to Newport, like say you're searching for Orlando at this time, then Newport is not shown. So it should be relevant to the text you're searching now, and it should be from your previous history. So we definitely want to do more than what the re-ranking process or the standard ranking, custom ranking is doing for us. So we want to take care of more signals than what the user chose in the suggest component. So we want to take care of, say, for example, the number of bookings for the destination, because people might have searched for something, found it in the first few results, but then might have actually ended up booking something different down the line, because search is so far away from the actual booking, actual booking or the checkout page. There are a few steps in between. And so we think like if you miss something and if the user has changed directions and booked something different, then we want to capture that signal. So we also want to take care of the number of bookings, or also the number of rental locations. So if somebody is booking a rental location, then we say, for example, if one city has or one town has more rental locations than a neighboring town, then it makes sense to show the one with more rental locations in the top of the list than the neighboring town. So we want to take care of that. And then we also want to, we are constantly adding a lot of hotels, rental locations, and destinations to our document. So we want to boost some of the ones that were more recently added. So these are some of the things we have added to the learning to rank piece, where it is taking care of more signals. This is still an experiment that is in process, because we do find some challenges in terms of response times, because it's being rendered in the suggest. So it is it's still being tuned for response times. And also we want to kind of figure out, even though we have based it on 4 or 5 signals, we want to tune the signals constantly, because it's still not very clear what signals are helping the user and what are not. So it's still an experiment in progress. And as many of you know, it's constantly an experiment in progress, the learning to rank piece. And we have a recommendations use case where it's more like a hybrid approach to recommendations we have taken. So there are many kinds of users visiting the website. So there are people who regularly book and have a rich history with us. There are people who are quite regular, but then they don't leave a lot of trace with us. So they're constantly clearing cookies, they change email IDs, they do a lot of things. And so we want to, we have built it using a hybrid approach, where we take care of many user segments. So the people who regularly book with us, the people who have some trace with us, and people who we think are completely new. So that's why we have several engines combined together. So one of them is collaborative filtering based approach on users' past bookings and searches. So I think many of you are familiar with this kind of approach, where you take a user's history and then you find users who are similar in behavior with this user, and try to recommend destinations that from the popular users. And then we also do that based on the user's location. So if a user is booking from the East Coast, then we try to figure out, like, so what are people in the East Coast, or what are people in New York City typically doing? Where are they going? So we want to recommend those destinations to the users. So it's a hybrid approach based on several of the recommendation engines. We have other use cases, which are like the geospatial use cases and polygon searches. So if you visit our Priceline app on iPad, for example, you will be able to draw a random polygon on a map and find hotels or rental locations included in that polygon. So that is another use case. And we do some aggregations on user reviews using named entity recognition. So for example, you've all typically experienced that when you are researching on hotels for some destinations, there are many hotels and there are many thousands of reviews on each of these hotels. So we want to surface the most important or most talked about reasons for hotels. So it could be like closer to an airport, closer to a train station, or maybe the hotel is kind of run down now. So in the recent past, the reviews have not been good. So all these needs to be surfaced on the top to the user. So we use named entity recognition to actually bring back the hotly discussed topics on a hotel and show it to the user. So I quickly want to touch on the monitoring pieces that we have built around the Solr ecosystem. So we monitor pretty much everything, all the way from Solr logs to JMX stats, slow query logs, long tail queries, everything, and all of them are streamed into Splunk. We like this one place where we could have a correlated view of all of the logs. So Splunk is pretty much our one-stop monitoring solution, and we monitor everything from response times to cache usage and overall traffic to the cluster and so on. So, some things that we have built out of the long tail. This is a slow query log, but some things that we have built out of the long tail use cases are. I don't know if you attended the talk by Rafael from Simatext on custom similarity. So he's talking about how it is fed to a different similarity engine to render different to see if they render different results. So we do that too on the long tail queries. And these are the SLAs we have come up with for our search system. So we pretty much look at many things from the response time to the customer, from what position the customer is picking the searches, and if the customer has changed the market from his initial search to somewhere down the line before he goes to booking. And then we also take care of how many attempts of suggest or search did he try in one visit to the website. And we also look at, of course, the failure rates and queries that fail to return any result. Surprisingly, there are queries that don't return any result because sometimes when the spell check component is the spell check component is fed something with too many misspellings, then those do happen. And then we also look at contribution metrics finally. So overall, what is the rate of bookings from and what is the drop from search to the booking, search to the booking piece. So this from the time we have implemented using the search using Solr, there are not a lot of optimizations that we did, except the ones I've listed here. The foremost being tuning the cache. So how much to give each kind of cache and how much overall memory to give to the JVM versus the how much to leave for the OS to manage is something we have tuned a lot. And we also tried to use all the different kinds of caches available, starting with query to filter and document cache. So those are some of the changes we did, and the cache was the most important, and we thought like after we tuned the cache, our response times were pretty good. And we also did a lot of parallelization. So we talked about several stages in the search pipeline. So we are now doing many of those things in parallel and kind of evaluating the results on the fly before we decide to show which one should be shown to the user. So as a next steps, I just wanted to list some of the things that are being worked on or some of the things that we are working on currently. So we are constantly tweaking the long tail. So there is always things that are challenging in terms of how a destination is known to the users versus how it's officially recorded on our system. So we are constantly looking and looking for colloquial names or something and adding them as aliases. For example, all of you know that the main island in Hawaii is called the Big Island, but it's not the official name of the island. So such things are cropping up very periodically, and we learn from the users' queries, and then we feed it back and we fix our system, or we kind of add them as aliases, and we try to query on aliases as well. So that is a constant work in progress. We would like to automate that piece a little bit. As of now, it is more like you bring up the searches that didn't render results, or searches that looked like they're not spelling errors but didn't render results. And then there's kind of an approval where a human looks at it and decides to add them as aliases to some of the destinations. So that's kind of like a feedback mechanism, but with a manual intervention. And then spell check with multiple phrases has been a challenge. So we do the search and suggest in multiple languages. So we don't have as many as 32 languages, which our sister company Booking.com has, but we do have 5 languages. And so many times it's a challenge when the user selects a particular locale, but is actually searching in a different locale, right? So user selects Spanish, but is actually starting to type in English. So as the indexes are very big, it is a challenge to search multiple of those indexes without when the locale is different. But we do fall back, like say after say 5 characters, if we are not able to find something on the locale that he has picked, then we search multiple locales. And spell check on other languages with multiple phrases is a big challenge for us. We are constantly looking to improve on that. And then we are also wanting to experiment on other similarities. So for example, most of the search terms, or most of the search terms in our collections are basically nouns, right? They're destinations. So we have not changed, though we have modified the similarity with the custom scoring and everything, we are pretty much using the default similarity from Solr. But we want to experiment on other similarities which are more suitable for nouns. There is some work in progress on that. And then the feedback mechanism on the learning to rank feature, where we want to consider more signals and improve on the input. And then of course we want to experiment on natural language based search. Okay, and last but not the least, we are hiring. And so we're looking for awesome search engineers to join us at Norwalk, Connecticut or New York City. So please reach us out on our career website, or you could reach me at my LinkedIn profile. So with that, I want to open the floor for any questions.
So how frequently you update your index, right? You mentioned the caches, how those gets impacted when you update?
Yeah, so we update the index pretty frequently. So because say for example, there could be some small towns which gain importance when there is a natural disaster. Say towns in Florida, when they are hit by a hurricane, they are searched more frequently. So we want to do the re-ranking and update the collections very frequently. This happens, let's say 4 hours a day or 6 hours a day. We are constantly updating the collection. So this is a good question that it does, though the document is updated, mostly only the custom score in the document is what we are changing. So we don't want the document to be taken out of the cache for that reason. So we use doc values for custom scoring so that it's held in memory and it's not removed from the cache at the time of reindexing.
Can you give some example of the NER on the reviews? So you mentioned that you use NER to pull up those reviews.
Yeah, so when there are hotel reviews, right, like so they're pretty long text, like a paragraph each review. So what we do is like we use the, I don't know which library we use, maybe the Apache one on named entity recognition. So we extract terms out of these that are pertaining to our domain, right? For example, in the case of hotels, it could be like if people are talking about a pool in the hotel, people are talking about the closeness of the hotel to an airport or train station. People are talking about the cleanliness of the hotel. And so these are all categories that are very relevant to the hotel's domain. So these are the named entities, right? So these are extracted from the review text and then they are aggregated so that they bubble up to the top. It's more like, so it's more like the tagging piece you see in blog sites, right? So they bubble up to the top. And so when the review score is rendered for a hotel, along with that, we also show entities that are more widely talked about for this hotel. It's not very straightforward because there is also a recency piece to it, right? So if a hotel was revamped in the past 2 years ago, we don't want to consider that. So that also has to constantly evolve. And the entities themselves will change for a hotel. So that's.
I have two questions. So one is, you mentioned you moved to Solr Cloud for scalability reasons. So one is, what's your scaling architecture look like, and two, do you have one index, multiple indexes, and how do they refresh across data centers? How fast or how quick?
So the scaling piece, like we are pretty much taking advantage of the sharding capabilities or distributed capabilities inbuilt in Solr Cloud. We haven't done anything in addition to that. So with Lucene, you know that the entire index needs to reside on each of the Lucene service or the service you built out of Lucene. So in the case of Solr, the collection is distributed. So you are basically being able to distribute the documents across several of the nodes and then aggregate them at the time of the search. So that's the distributed piece or the scaling piece. And sorry, I forgot your next question already.
Do you have one index or you keep multiple indexes? How do you decide how many indexes you're going to create and based on what criteria?
So we do have multiple collections. So it also depends on the product. So for hotels, for example, we have multiple collections, like one for each document type. Say points of interest are used across multiple products, rental cars, hotels, and air. So we use one points of interest collection. For hotels, it's a different collection, and then we use a different collection for the recommendation piece, right? So when a user comes and searches, does a search, we automatically are building recommendations for him in the backend, right, based on his history. So that is a different collection. And then we have all the feedback, the input signals from the user going to a different collection. But those collections are kind of constantly retiring documents, because I don't want to personalize your search based on something you did 6 months ago, right? So those are kind of like having very volatile documents which are constantly being retired. So there are multiple.
Can you talk a little bit about your ingestion process? Do you do like document enrichment at ingestion time, or what else do you do?
We do normalization on the text, right? So for example, we do common ones like MT is changed to mount, or PT is changed to port, and like a lot of domain specific normalization we do at the time of indexing. We don't do a lot of enrichment other than maybe, so for example, if somebody is searching, the people normally copy paste text from other websites. So they are giving you the entire name of the airport, the official name of the airport. Then people normally, but when you're actually typing, you don't say airport, right? Like, so we do some simple enrichment like that. But other than that, nothing much.
So, two questions. What's the size of your index corpus that you have across to a specific market, like hotels? And the second question is, you mentioned that you're trying to tune your signals in the LTR based on experiments, right? So, how are you measuring which feature in your LTR is useful or making use for better DCTs?
So the size of the collections, as you said, it's a little challenging to measure. It's definitely not in terabytes. It's in the, like, I would put it somewhere like 20 to 30 gigabytes per product. And I'm not counting the recommendations and the user signals at this point. And measuring LTR signals, that's been the challenge for us actually. So business typically doesn't have the patience to test one signal at a time. So we are testing like 3-4 signals, and so something is winning. So everything in our website is an experiment, right? So everything is measured in terms of what is the conversion, what is the contribution it is bringing to the website. So, but so typically there's no, people don't have the patience to do a signal at a time. So we're testing 3-4 signals, and then there arises a question, which among these are more relevant? So we still don't have an answer for that piece. It's still an experiment. Like, we're constantly changing signals, seeing what combination works better, that kind of thing.
When you started with Learn to Rank, was that net new functionality, or was there some basic functionality you had done with like manual boosting?
So all the other stuff I talked about already existed. The learning to rank piece was a new piece. So it was measured against all of those other functionality. But response time, we figured, is a very critical, very, very critical to our suggest functionality. So learning to rank may produce more relevant results, but if it is losing on response times, we do see a deterioration in the experiment.
Yeah, just a follow-up question on the frequent updates. You mentioned that you're using doc value fields for storing the frequent update values, but does that mean that you're not going to start a new searcher when you have updates on those fields, or?
Yeah. So it's not a lot of fields, it's just one field with the custom rank. But we do update the collection for other reasons, right? So rental locations have moved, then we do update the actual collection. But the ranking process is more frequent than refresh of the collection for other reasons. So the rank alone is stored as a doc value in memory.
But
So-
when you reload the core, I mean the collection, right, the caches gets evicted anyway.
You don't have to in the case of doc value.
Okay.
So does that mean that the change to that field, even without create a new searcher, the searcher will still be
Yes.
able to fetch the new value?
Yeah.
Okay.
You mentioned that the Solr caches gave you a big improvement in performance.
Mhm.
Can you tell us a little more about that?
So there were lot of optimizations, but very simple ones like typically the default that comes with Solr, very little is allocated. It depends on your use case, but very little is allocated to the document and the query cache. And we found that increasing the size of the cache and
Did you double, triple?
honestly don't remember recall. Yeah, so by tuning I mean like those things, and basically taking care to see that the cache is not evicted when it doesn't have to be, right? So we keep monitoring the cache hit ratio constantly for that.
And also learn to rank, right? So you are learning at an aggregate. It is not one-to-one personalization, right?
Yes, it's not personalized. So personalization is top of the learn to rank results.
Learn to rank is basically an aggregate.
Yes, yes. Those are based on consolidated signals from all the users. So thank you very much.